Good day, everybody. This is, I think, the third webinar in the new series of Mike Plus webinars. Yeah, separate systems. It's about modeling urban drainage with separate systems in Mike Plus today. And it's not so much about separate systems only. It's generally about catchments which are connected to more than one manhole or more than one pipe. And the entire process relies on catchment connections, which are more flexible in Mike Plus than they were in Mike Urban, and more flexible than in many other products on the market. So if you're used to a model where each catchment has just one receiving node, you'll see something different today. Oops. My name is Thomas Telligti. I'm a global specialist for Mike Plus. I'm based in Vienna in Austria. Some practicalities, no, first the agenda, then the practicalities. So agenda is a few words about urban drainage systems, a look at the workarounds we've used in the past, I would say. Then Mike Plus catchment connections at the core of today's webinar. A tutorial where we import data and edit some of the catchments. Urban drainage systems. I'm struggling with my two screens here. We traditionally look at the two main urban drainage systems. The combined system, where the wastewater and stormwater flow together on the catchment already in one pipe, and then use one pipe in the street as well. And the other one is the separate system. Wastewater and stormwater are kept in separate pipes on the parcel itself, but of course also in the street, in the main pipes. And this is the very traditional classifications, and it looks most at the pipes. But in reality, if we talk urban drainage systems, we have also to look at the catchments and what happens on the parcels. And I'm using catchments and parcels at the same time. The whole process is sort of built around a parcel-based approach where each parcel is a catchment. I find that this is, with today's data, a viable approach to modeling catchments. And once you do that, you are really in the situation that you look at catchment connections on this detailed level. Yeah, so the separate system is the other traditional system, but already if we look at the separate systems, we don't cover the full picture. In the next slide, you see ortho photograph, and here foul sewer, and the roofs here. And I've marked the roofs, but in principle, you could also, what I say applies also to the streets or to the parking lots. So they don't connect to a stormwater pipe. They deliver the stormwater directly into the lake. So no need for a second pipe. Same goes for the buildings here along a river. Stormwater flows directly into the river. And the third one is here, new development, and this is a modern one. So stormwater goes to the groundwater, and only the wastewater is connected to the foul sewer. So this is a separate system, but there is no stormwater pipe here, and we treat them differently. And the next example is just the other way around. It is a separate system, if you like, but there's only a stormwater pipe, because we look at the street, and along the street or on the streets there are no inhabitants, there is no wastewater produced. So this is a pure stormwater system. And again, you see I'm talking about a parcel-based approach here because this is the road parcel here. And the last system I want to talk about is the so-called hybrid system, which becomes more and more popular. And the big difference to the separate system, it looks similar to the separate system because it has two pipes in the street. But the big difference is that it also treats polluted stormwater in a different way. So the wastewater is mixed with polluted stormwater, and this flows towards the treatment plant. And then the majority of stormwater goes into the separate pipe and then into the river. And this is, sometimes it's called a partially separate system. And in the best case, this has been built on purpose, precisely to cater for the polluted stormwater. But in reality, they also exist for more accidental reasons, because we have wrong stormwater connections to the wastewater pipe, or the whole system is a grown one, and you have new stormwater pipes, but they are still going into a combined or wastewater system. So those are the 5 types I want to talk about today and to show you how to model them in Mike+. Before we do so, let's have a look at the workarounds for separate and hybrid systems. And we have proposed those workarounds ourselves in the past when we were still using MicroUrban. The first one is for separate systems, where we use catchment and load points. Sorry, catchment and load points. So those are the catchments, squares, so symbolic catchments. And the red stars are the load points. So the load points accept wastewater only. If you haven't used them so far, they still exist in Mike+. So you could, in principle, copy this approach as well. But you have to create a load point for each catchment. We've done that automatically. That's why they sit in the middle of the square, but they could sit anywhere. And these load points accept wastewater and are connected to the foul sewer. And the catchments, they are responsible for the stormwater and are connected to the storm sewer. Still, you have to at least create the load points, and if you want to avoid that, you could use the more advanced approach I'm talking about today. You can't model a hybrid system here because the load points don't accept stormwater, not a drop. So if you want to really model, or if you wanted to model a hybrid system, you need double catchments. So we have here catchments. Some of them are wastewater, some of them are stormwater, some of them are combined, and I've hatched them so you can see the single catchments here, the combined ones. But here you have 2 catchments, one on top of the other. So this is the combined one, responsible for wastewater and a part of the stormwater, and the stormwater one responsible for the other part. But to work with that, you have to double the catchments and split the imperviousness or the impervious areas, the runoff generating area between both catchments. That's a lot of manual work. Could be done through an import, but then it's hard to work with these catchments one on top of the other, because if you click on one, you always click on the top one. You can't touch the bottom one. So some clients applied a negative buffer on the top one so that it was slightly smaller than the bottom one, and then you could click on the bottom one. But anyway, it's really cumbersome. And that's why we have loosened or expanded the catchment connection approach in Mike+. We use the catchment connections editor in a second, where it has actually 3 tabs. We don't look at routing and description. We only look at the connection, where we define the receiving node, could also be a link, and we define the load type. And then we have a couple of tools to add, replace, and delete catchment connections. But let's have a look into Mike+. I've no wonder prepared a setup to show you. I'm working on a virtual machine here. So we have a network here, the same you've seen already on the slides. And I'm starting by creating a new catchment. Somewhere here. There we are. I've predefined some symbology, but we'll have a look later onto the symbology. And now I create a catchment connection. I add one. I click on the catchment and I click on a node. And this creates a line of type standard. If we open the catchment connections, you'll see this is a standard catchment connection which accepts 100% of the runoff and 100% of the catchment discharge. So the wastewater. And this is how catchment connections did work in Mike Urban in the past. But now we can add a second catchment connection. No, I didn't click on the junction. And now we have 2 catchment connections. They connect to different nodes, 808, node 19. But you see there is an error message because it tells me the sum of catchment discharge fractions shall be 100%. We now try to get stormwater and wastewater twice, and that's not how it should be. So let's instead use a partial stormwater connection, and I'll explain those parameters in a second. So a partial connection only takes a part of the runoff, and one could take whatever 35%, and the other one, I'm also changing that to stormwater partial, would take 65%, and suddenly the error message disappears because now the sum is 100%. And on the map, it doesn't refresh automatically. You see that the symbology has changed to stormwater partial. Let's have a look at the 6 different types we have here. And I'm switching back to the slides. So we have 6 load types for catchment connections. The first one is the standard one, so it takes 100% runoff and 100% catchment discharge. Orange here doesn't mean error, it means a lot of. It's perhaps not a very wise color I've chosen. Then we have wastewater total, which doesn't accept any runoff, but takes all the wastewater, and stormwater total, which is just the opposite. It accepts all the runoff and no catchment discharge. And usually they come as a pair. So those are the total connections. And now come the partial connections. Combined partial is similar to this one, but you can choose any fraction between 1 and 100% for the catchment runoff and any percentage for the catchment discharge. And then wastewater partial, which is sort of the correspondent partial connection for wastewater, and stormwater partial, again, which is corresponding to the stormwater total, but it accepts something in between. There are more combinations, more in principle, there are more connections possible, but we've decided to restrict the number of possible connections to 6. In theory, this one would be enough to do everything you want, because you can choose any number, 0, 100, 50, 60. But the problem is that it's difficult to track errors and to see what's really happening on the catchments and the catchment connections. So we feel it is better to have a bit of a choice, and so it's easier to track what's happening on the catchments. My recommendation is, or let's put it the other way around, you have to be careful. You get a warning in Mike Plus if the sum is not 100%. You've seen that, but it would still work. So the engine runs and you get results, but it means that you lose water. So you have more runoff than pipe flow. Now this was possible in Mike Urban too. I mean, you could have some catchments which are not connected to the sewer system. Not in Mouse, it's only possible in Mike 1D. So some catchments don't deliver water into the sewer system, and there is a difference between runoff generated and pipe flow in the pipe network. But this becomes even more relevant as each of the connections could have a total less than 100%. And I mean, you have already the hydraulic losses on the catchments. Perhaps you have an imperviousness which is smaller than 100%. So this is already you have already parameters where you introduce a difference between rainfall and runoff. And these catchment connections are the next step where you could introduce a difference between rainfall and runoff, not pipe flow, not runoff. So a difference between rainfall and pipe flow. And if you are aware of that, and if you want to do that, some of our clients do that, then yes, go ahead. But the other approach is to make sure that we have always 100% here and you don't lose any water between runoff and pipe flow. Okay, I hope this was not too confusing. If you have questions, just put them into the question and answers along the way. So those were the 6 load types I wanted to talk about. I think I go back to the slides. And now let's see how we apply them in the urban drainage system. And I'm coming back to these 5 types. This is a combined catchment with people living here in the house plus runoff, and we use the standard connection, which takes all the rainfall and runoff. Then we have the separate system, again, with wastewater and stormwater, and we connect it to a storm sewer and a foul sewer with a total rain, stormwater total and wastewater total connection. And the wastewater total refuses runoff, and the stormwater total refuses wastewater. So that's how we split the catchment. Then we have the wastewater only. Two remarks. First of all, here it connects to a foul sewer, but it could also connect to an existing combined system. Imagine this is a new development and it has some local infiltration or low impact development, so no stormwater, only wastewater. And this shows you, if we talk urban drainage, it's more about the catchments together with the pipes than only looking at the pipes. Second remark, in principle, you could also use a standard link here. If this catchment creates no runoff, because you have chosen the hydraulic parameters so that it doesn't create any runoff, then there is no need to use a wastewater pipe. You could also use a standard pipe because there is no runoff to hold back from the system. Still, I think it's easier to understand how the whole system is meant if you put a wastewater connection only. By the way, probably the pipe on the parcel itself is a wastewater only, and it's not connected to any possibly it's very small and so on. So it is a wastewater connection. Same goes for stormwater. I mean, this is now a street. There is no building here. It only creates stormwater, and this stormwater is connected to the storm sewer. In theory, you could also use a standard link because there is no wastewater produced here, but I think it's easier to understand. And that's the most complicated example here. We have one pipe going to the combined sewer and to the treatment plant. So this one has to take all the wastewater, and it will take a part of the stormwater. And then we have the stormwater partial, again, which takes the remainder. So this is load type 4 and load type 6. And now let's get back, just looking at the time. Yeah, we are good in the time. At the tutorial, I'll delete this single catchment here. In the background, I've prepared a data set with parcels. And something is selected here. Yeah, I've created a shapefile with parcels. Yeah, if you want to import, you have to prepare your data in some sort of GS system. Let's have a look at the attribute table of this shapefile. And my import corresponds to this data structure here. Your data structure might look differently, but well, then we have to adapt the import, but anything is possible. I'm sorting this according to the urban drainage system. So what attributes do we have? We have a parcel ID, we have the urban drainage system. So these 5 types, I need that for the import. Personal equivalence, the density is not really needed. Area and impervious area to create the imperviousness. Fraction towards the wastewater treatment plant, towards the stormwater or river network, and then the nodes. So with the combined system, all the stormwater goes towards the treatment plant, and this is the node of the combined system. I don't have diffractions for the wastewater because in this example setup, or I think in most setups, it's always clear which node gets the wastewater. It's the one which is connected to the wastewater treatment plant, and it always gets 100%. I can't see a system where, well, I'll show an example later on, but in principle, it's always the entire wastewater which goes into one node. Then we have the hybrid system. You see that there are two nodes for the stormwater, and here are the fractions, 0.4 and 0.6 percent, 40% and 60%. This is the same amount for, or the same fraction for all the catchments. This was the case in this general master plan. If you have more detailed data here, those are the hybrid catchments, then each parcel could have an individual fraction. So this really depends on the source data. In our case, it's always 40, 60%. Then we have the separate systems, of course, two nodes, and fraction of stormwater is 100% to the stormwater node. Separate, separate, separate. Then we have stormwater. They only have a stormwater node, no treatment plant node. Again, 100% goes into the stormwater node. And then we have a few wastewater systems. Well, those are the wastewater nodes. And again, those two fractions are about stormwater, no fractions about wastewater because they accept all the wastewater. I think I've in the slides I've also added, yeah, this is just a representation of what I've just shown you. Now I've created an import configuration, and this import configuration has three parts. Let's see, tools, import and export. And this is version 25. So this import looks, this import looks at shapefiles here, shapefiles into this directory. And this is my shapefiles. It's this parcel shapefile, this polygon shapefile. And we have three sections here. The first one simply takes these parcels and creates the catchments. Also computing the impervious area for model A. You could do something similar for model B or the other hydrological models we have. But then we use the same polygon and create catchment connections. And first we create the catchment connections towards the wastewater treatment plant, which means that we only look at urban drainage systems combined, hybrid, separate, and wastewater, because they have a connection to the wastewater treatment plant. And here we define the load types, depending on the urban drainage system. And the third section is to generate the stormwater connections. Only those systems have a stormwater connection. And again, this is the load type. So if you verify, we get an OK down here, and we run the import. So let's have a look at the map. I've switched off the parcels, and now I see the catchments. They have the same colors. Let's start down here. So here we've created the separate systems, and you see that each of these catchment has two connections. We can look at the connections also if we open the catchments editor. So here, open the catchments editor, and you see that you have here two connections. One is for wastewater total, one is for stormwater total. So those are the two lines. Yeah, disregards the fact that this is red, shouldn't be red. This is fine. It sums up to 100%. Yeah. Then here we have the here we have a wastewater system. So it accepts all the wastewater, and it goes into a combined system. No stormwater because here's the lake. Then the hybrid systems, for example, this catchment here. So it has this combined partial, 40% runoff, and the other one takes 60% runoff, the stormwater partial, and the wastewater goes in the combined partial to node 360, which is, yeah, this one. Then pure stormwater systems is usually the streets. And here, the combined systems. So the import did work, and yeah, as usual, you don't create catchments and catchment connections from the scratch. You usually import them, and then you edit something here and there with new developments or some scenarios you want to look at. And this is precisely what I want to do right now. I want to turn this catchment into a hybrid one with wastewater and a part of this stormwater into that node and the remaining stormwater into that node. Let's see how I can do that. I use the editor, and if I click on the line, it will open the connections editor. Perhaps I should, just to make sure I don't make any mistakes, I should label my node with the ID so that I'm 100% sure I'm working on the proper connections. So I want, if I'm correct, it's 707.1. Yeah, it is. So this one should become a combined partial. It takes all the wastewater, that's fine. And it should take whatever, 30% of the catchment runoff. Once we've changed this, you see we have this warning here. And then I use the connect catchment add connection tool. We have two now. This is new in update 1, by the way. So you can choose whether you want to replace the existing connection or add a connection. Now we want to add a connection from here to here. And standard is the standard link, which is not the one I want. So I have to change this. It goes to 752. Yeah, perfect. So this should become a stormwater partial. And I think 70% is the correct figure. Again, it doesn't refresh immediately. So you have a combined partial and a stormwater partial. And that way you sort of may add catchments, edit catchments. I want to show you another example, also showing a trick, which is not that obvious. You see this is a very large street, a long street and it's connected to this manhole here. And usually you would, yeah, you want the street to, yeah, reach each manhole. And therefore, I will split the street manually. There are more clever ways to do that, but I do that manually. And I want to reassign the catchment connections manually. So let's start with splitting the catchments. Slightly downstream of the manhole. And you see the catchment connection is the same as for the total catchment, the unsplit one. This only splits catchments which I cross the whole length. So it didn't split these catchments here because I didn't cross the entire catchment. Yeah, let's leave it with these 1, 2. No, this one is the last one I want to split. I could now select them, use the field calculator to change the catchment connection. But again, I want to show you something different. If I now replace the catchment connection from here to here, this is a standard link, standard connection, standard load type, but I want this stormwater only. And I don't know whether you're aware of the fact that the property view, I don't use it usually. I use the editors. Some colleagues use the property editor, prefer this one to edit data. But the important part is here, you can change the default values. So if my catchment connections editor is open, I can change the default values for any new element. So I changed that to stormwater total. And now, if I go back to the map and use my connect catchment tools, replace connection, it's still active. It turns into the blue line, which is stormwater total. And now I'm pretty fast, just changing one connection after the other. So even if you do that manually, it's quite a nice way to work visually with this tool. Yeah. Okay. I think this was the last thing I wanted to show you with the tutorial. Don't forget our YouTube channel on Mike Plus YouTube channel. It's getting new additions again and again, also with the latest release. Yeah, and if you enjoyed this webinar, spread the word. For training in general, contact Evan. If you have support questions, send them to Mike. And if you have questions specific to what I've shown you today, well, write to me directly. Okay, thank you very much. Have a nice remaining day and hope to see you soon in one of our events or in one of our support cases or in one of our trainings.